So now we're going to apply that reasoning to this problem here. So I'm going to jot down the formula one more time, that when we have a plus b squared, that's going to give us a squared plus 2ab plus b squared. And I had mentioned before that we really want to think about these as the first thing squared, the middle thing there, that's the product of our two values times 2, and then b squared. So in our example here, our a value is 2x. Our b value is -3, because again, when there's a negative sign in a problem, that's just attached to the number after it. So when we go to our a squared area, that's our first term squared. If we take 2x and square it, that gets us 4x squared. For our middle area, if we take our two terms and multiply them together, so 2x times -3 is -6x. And then we're going to double that. So if we double that, we get -12x. And for our b squared, we take -3 and we square it, and that's going to get us 9. So overall, we're getting 4x squared minus 12x plus 9, and that's how we multiply this out. And again, this might seem easier to FOIL it out in just combined like terms, but please trust me. I know it's coming up in the course. It's going to end up being easier if you start to get used to this formula here, so you can start to figure out how to square binomials. When we start to introduce radicals into the mix, other complicated things into the mix like logarithms, it's going to be easier to know how to apply this formula. And also when we're factoring, we're going to be able to go backwards. If we can identify when we see a perfect square like this, we can factor it back into a perfect square. So that's why I want to get a little practice right now with using this formula.